Welcome to Centum Maths guys. Today we discuss exercise 1.2 from question 3 onwards in class 12 Ncert. Fine. So prove that the greatest integer function f is such that r tending to r given by f of x equal to floor x is neither 1 to 1 nor onto, where floor x denotes the greatest integer function less than or equal to x. Fine. So this symbol is known as floor x, that is called as greatest integer function less than or equal to x. For example, if we say any number, okay, so it will be rounded to the integer that is less than or equal to x. For example, if I say 1.5, the floor x is 1. 2.9 also it is 2 because it is less than or equal to x. Now we will check for the 1 to 1. So what is 1 to 1? So if f of x equal to f of y, then x should be equal to y. So we will take some value like f of 1.2. So what is f of 1.2? It should be less than or equal to x. Okay. So the nearest integer is 1. We take 1.7. Again it will be less than or equal to the x. So we got 1. So f of 1.2 equals f of 1.7, but 1.2 is not equal to 1.7, therefore it is not 1 to 1. So checking for the onto, so we will take okay any value, okay, 0.5, but floor x function is a function which has less than or equal to x. So it should not be the decimal number. So this is not onto because 0.5 is not a integer. So the greatest integer function floor x is neither 1 to 1 nor onto. Coming to the fourth derivative, show that the modulus function f is such that r tending to r given by f of x equal to modulus x is neither 1 to 1 nor onto, where modulus x is x if x is positive or 0 and modulus x is minus x if x is negative. Fine. So what is this function? Modulus x. Okay. So f of x is modulus function. So modulus is nothing but the negative value, it becomes positive. For example, modulus of minus 2 is 2, modulus of minus 1.5 is 1.5. So any negative value, it will become positive value in the modulus function. So that is what it is given in the statement. It will be little bit confusing. So modulus x is x if x is positive or 0. Yes. So modulus x equal to x if x is positive, of course. So modulus of 2 is 2 and modulus x is minus x if x is negative. So minus 5 is, so it is minus of minus 5. So minus of minus 5 is plus 5. So that is what it is given in the statement. Fine. So now we will check for the 1 to 1, then on to. So what is 1 to 1? For example, f of minus 5. Okay. So what is modulus of minus 5? 5. What is f of 5? It is 5. So f of minus 5 equal to f of 5. But 5 is not equal to 5. Therefore it is not 1 to 1. Checking for the onto, what is the domain given? R. So real numbers will take any negative value. So modulus x is minus 7. But modulus value can never be negative. Therefore this is false. So this is not onto. Therefore modulus function is neither 1 to 1 nor onto. Coming to the fifth derivative, show that the signum function f is such that r tending to r given by f of x equal to 1, 0, minus 1. So f of x becomes 1 if x is greater than 0. So f of x is 0 if x is 0, f of x is minus 1 if x is less than 0 is neither 1 to 1 nor onto. Fine. So this is called as signum function, that is 1, 0, minus 1. So these three values are called as signum function. So now we check for the 1 to 1. Okay. So for example, we will take f of 1. So what is f of 1? Greater than 0, we will get 1. So what is f of 2? Greater than 0, we will get again 1. So f of 1 is equal to f of 2, but 1 is not equal to 2, right? Therefore, this is not 1 to 1. So checking for the onto, okay. So the domain is given as a real number. So we will take any real number. So f of x equal to 5. Signum function won't have the value of 5, right? See, it will have only 1, 0, minus 1. So this is false. Hence, this is not onto. So we can say that a signum function is neither 1 to 1 and nor